Hello everyone, my name is Qcode and welcome back to our Love Lua Tutorialy series thingy episode 28. Today we're going to be going over physics in Lua and Love 2D, specifically AABB platformer physics. You can see right here I have Lua test copy on my desktop as well now, along with Lua test. That's because I just wanted to demo it and make sure I had everything right before I fully programmed it. I will be still going along in my usual style where I write out everything and explain it to you bit by bit. However, that's just the explanation for why that folder is there. Before we get into this, I won't be doing tutorials over them, but I actually would recommend you use a library instead of watching this tutorial. The libraries have a lot more functionality. The three most common ones, I believe, for Lua and Love 2D are Bump, PhysX, and Hard-On Collider. I would recommend using one of those because they have AABB support, along with various other shapes. Plus they don't necessarily act like real physics like the Love.physics module does, so your character won't slide down slopes or anything like that. However, if you like reinventing the wheel like me, and you like saying I've done everything in this game right down to the physics, like me, then you can watch the tutorial and follow along. Inside of our folder here I'm going to make two new files. First one I'm going to save as block.lua, and the second one I'm going to save as physics.lua. And now I have to require both of these files, as you usually do. Require block and require physics, and I'll save that. So now first thing I'm going to do is in the block.lua file, I'm going to set it up very similarly to the Goomba file, except I'm only going to be using one function. So first I'm going to make blocks equals that, and that's going to be our physics blocks table. Then I'm going to say function block underscore create xy table.insert blocks, and then insert into that a table that has x equals x, y equals y, width equals 32, height equals 32, x speed equals 0, and y speed equals 0. Those are just our usual physics values. Next up we're going to be actually creating our physics block. So this is where we have all of our tile codes set up so it's sorted into a map properly. Now what I'm going to do is I'm going to say inside of this loop, if map tileSetData x, y, which is the tile you just filled out, doesn't equal 0, then we're going to create a block for it. So block underscore create x minus 1 times 32 and y minus 1 times 32. And that'll line them up with all the tiles, each of the physics objects. Now into player.lua I'm going to do a few things. I'm going to comment out these 4 lines right here. That's the thing that stops us colliding at the very bottom. However, we don't need that anymore because we're not going to be colliding on the very bottom, we're just going to be colliding on individual blocks. So if we build this now, you can see we just fall straight to the ground. In physics.lua I'm going to say function calculate collision, and then I'm going to have 3 arguments, v1, v2 and dt. v1 and v2 are tables of the objects that are colliding, and dt is obviously just the delta time which we're going to pass on through. Inside of calculate collision we're going to say if AABB v1.x, v1.y, v1.width, v1.height, v2.x, v2.y, v2.width, v2.height, then that means our objects are inside of each other, and we need to resolve that collision. First thing I'm going to code is just the collisions for whether you're on top of the block. So first thing, I want to check the x to make sure you're in between the block's outer boundaries. So if v1.x plus v1.width is greater than v2.x, that means if our far edge is farther than the left edge of the second one, or v1.x is less than v2.x plus v2.width, so that way we've guaranteed we are inside of the block on the x positions, and v1.y plus v1.height is greater than v2.y, and v1.y plus v1.height is less than v2.y plus v2.height divided by 2. So I'm going to draw up one of my amazing diagrams to show what this is checking right here. let's say this object right here is the block, and this one, say here, is going to be the player. This side right there is the side that is represented by v1.x plus v1.width, and this side right here is represented as just v1.x. So all this collision statement does is check whether this side is greater than here, or this side is less than here. Now the thing with the y and the height is it splits the block in half and checks if the player is something like this. So if the player is like that, then the player needs to be shifted up a few pixels and it will adjust that. So that's our check, and then all we need to do is provide the reaction for it, and our reaction is going to be v1.y speed equals 0 because we want to cancel out the gravity, and we're also going to say v1.y equals v2.y minus v1.height, which will set you back just standing on top of the block. Now we actually need to call this function. So in game.lua, just underscore the player underscore update and Qcode'S underscore update. I'm going to say for I, v in pairs, blocks do calculate collision v1, v2, dt. So now if we build this, you can see we are once again colliding on blocks. Hope we once again have that bug from the beginning where sometimes we press the up button and we don't jump. This is just due to that we're adding the x speed and y speed in the wrong place. So if we put it here right before the check collision, that will fix our problems, and now we can jump in just the correct places. Whether you'll notice obviously left and right collision is not implemented in the slightest, so I'm going to do that now. It's pretty much the same thing except flipping x for y's and flipping greater thans for less thans. This is going to be our down collision because the player is moving down. Now we're going to say else if v1.x plus v1.width, we can just copy this first one because we are doing the up collision, and v1.y is less than v2.y plus v2.height, and v1.y is greater than v2.y plus v2.height divided by 2. So that's just the bottom half of the block. Once again, we're going to set the y speed to 0 and say v.1.y equals v2.y plus v2.height because we want it to be at the bottom of the block instead of the top. That will be our up collision. Now again, we need to say else if. Now we need to switch it up a bit. So if v1.y plus v1.height is greater than v2.y, or v1.y is less than v2.y plus v2.height, and v1.x plus v1.width is greater than v2.x, and v1.x plus v1.width is less than v2.x plus v2.width divided by 2, then this will be our right collision. So this time we say v1.x speed equals 0 and v1.x equals v2.x minus v1.width. And then finally we copy in the first part, which checks if we are inside the y position properly, and v1.x plus v1.width, and v1.x is less than v2.x plus v2.width, and v1.x is greater than v2.x plus v2.width divided by 2. Then that's our finally left collision. v1.x speed equals 0 and v1.x equals v2.x plus v2.width. Now if we calculate all this, we should get right collisions as well. We have left collisions, right collisions, all the collisions. Now there is a few small bugs we need to fix in this. Number one is when you get above half of the position on the top block, you snap up immediately. The way we're going to fix this is we're going to say in the down collision we have to be moving downwards. So, and finally, v.y speed is greater than 0. That should fix that problem. A-OK. See, now you can clip the corner and still get over. Number two is this problem here where you can get trapped under a block and get snapped back down, which makes you lose your momentum and is fairly annoying. So to fix this problem, I'm going to add a tiny little buffer here of just 5 pixels. So what I want to do is I'm going to change this to an AND statement, and I'm going to make it so it has to be past v2.x plus 5, and it needs to be less than v2.x plus v2.width minus 5. So that gives you a buffer of 5 pixels on either side to not get caught in the down collision, and that fixes our problem. And it's also nice to have a buffer around the up collision, because sometimes, you know, when you're jumping and when you're trying to platform around a block, it's nice to have it so you can slip around it instead of like bumping into it by 1 or 2 pixels, which is incredibly frustrating for a lot of people. Thank you everyone for watching this episode. Next episode, in episode 29, I'm going to be going over how you can add slopes to this, so we're going to be expanding it just a tiny bit more, and that should be fairly fun. I hope to see you all next time. Bye.